Pleasant day greetings to the learners. In this video lecture, we are going to learn about what is an electromagnetic wave. As a physics student, we will encounter electromagnetic wave in many areas of physics as well as in our day-to-day life. So we have to understand the basics of an electromagnetic wave. Electromagnetic waves are EM waves that are nothing but the oscillation of electric field and magnetic field, or they are the physical field that is created by electrically charged moving objects. So a field is a region in which each point is affected by a force. So to understand this, let us imagine a candle in a room. So around the candle there will be a heat field. When you stand near a candle, you will experience an enormous amount of heat, and when you distance yourself from the candle, the force or the heat experienced by you will be a smaller amount. So when placing a candle, we speak of a heat field. And the strength of a field, which is represented by the field lines, the closer the lines, the stronger the forces in that part of the field. So when you stand near the candle, you will experience an enormous amount of force. That means the field lines are closer, nearer to the candle. And when you stand apart from the candle, the field lines are very distinct. That means they are separated by a larger distance. The field may be the heat field or an electric field. It may be either a scalar field or a vector field. When we speak of a scalar field, we speak only about the magnitude of the force and not about the direction. That means when you place at a particular radius from the candle, once you place on the circle of particular radius, you will experience the same amount of heat, not a varying heat. But when you speak of a vector field, you speak of a force and a magnitude, that means and a direction. That means you experience some amount of force in particular directions. That means that force that fields are vector field. And examples of fields are gravitational field, which is a scalar field, then electric field, which is a vector field, magnetic field, electromagnetic field, temperature field, and wind field. So this diagram represents a field. These closer lines represents the strength of the field. Closer the field lines, stronger the force. The far apart field lines represents the weaker force. So what is an electric field? An electric field is a field or space around an electrically charged object where any other electrically charged object will experience a force. Now take us a positively charged electron in a space. So around this positively charged electron, there will be a field which is represented by a field diagram. What we mean is a field diagram. So already we have said that electric field is a vector field. So when we place a positive charge, the field lines are outward the object. That means when you place another positive charge inside this point, then it means this source point will pull away the test positive charge with a magnitude represented by this line, and it will pull away the test positive charge in this direction. So this arrow mark represents both the magnitude and the direction with the positive charge or the test positive charge will experience. When you place a negatively charged electron, then the field lines are directed towards the charge. This means that when you place another test negative charge, then this means that it will be repelled towards this direction with a magnitude of this strength and a direction. Let us imagine what happens when you place a negative charge in a positively charged electron field. Then it means this electron will be attracted towards that positive charge with this magnitude and in this direction. So what we understand is, around a positive charge, the lines are directed away, and around a negative charge, the field lines are directed inwards. So this diagram represents an electric field or electric force. Then what is a magnetic field? A region of space near a magnet, an electric current or a moved charged particle in which a magnetic force acts on any other magnet or electric current or moving charged particle. We can picturize now the electromagnetic wave. Here you can see that the blue lines represents the magnetic field and the red lines represents the electric field. So you can clearly see that the red-headed arrows oscillates in x direction, and the oscillating blue lines are accelerating in the y direction. The propagation direction of electromagnetic will be both perpendicular to the electric field and the magnetic field. So what we have today understand that electromagnetic wave is a combination of oscillating electric and magnetic field. A field is nothing but a force region. Some fields may be a scalar or some fields may be vector. Scalar, there will be only magnitude of force and no direction. When you speak of vector field, you speak both of the magnitude of the force and the direction in which a test particle or a testing object will experience force in that directions. Thank you.